tell us a bit about projects. I mean, you don't need to go into detail with client names or whatever if that's inappropriate, but it would be interesting to hear some examples of use cases of Bayesian statistics in the wild, enabling capabilities that other kinds of modeling approaches wouldn't.
Yeah. No, definitely. Yeah, so of course I cannot enter into the details, but I can definitely give you some ideas. One I can actually enter into the details is a project we did for an NGO in Estonia, where they were getting polling data. So every month they do a poll of Estonian citizens about various questions. These can be horse poll races, horse races polls, but these can be also, news questions like, do you think Estonia should ramp up the number of soldiers at the border with Russia? Do you think same-sex marriage should be legal? Things like that.
I hear some Overton window coming on.
Do
No,
you?
that's what I thought. I thought we might go there. We had this is now. I'm completely taking you off on a sidetrack, but
Yeah.
Serge Massis, our researcher, came up with a great question for you because you had
Uh-huh.
Alan Downey on your show, who
Right. Yeah.
is an incredible guest. I absolutely loved
Yeah.
having him on our program. So he was on here in episode number 715, and in that episode, we talked about the Overton window, which is related to what you're kind of just talking about. So, kind of, people, what is, how does society think about, say, same-sex marriage?
Yeah.
Where, if you looked 100 years ago, or 1,000 years ago, or 10,000 years ago, or 1,000 years into the future, or 10 years into the future, at each of those different time points, there's a completely, well, maybe not completely different, but there's a varying range of people who think, like, what's acceptable or what's not acceptable. And so, and this is, we were talking earlier in the episode about bias, so it kind of ties into this. You might have your idea as a listener to this show. You might be a scientist or an engineer, and you think, I am unbiased. I know the real thing, and but you don't, because you are a product of your times. And the Overton window is kind of a way of describing this. On any given issue, there is some range. It would fit a probability distribution where, there's some people on a far extreme one way and some people on a far extreme the other way, but in general, all of society is moving in one direction, typically in a liberal direction on a given social issue. And this varies by region, it varies by age. Anyway, I think Overton windows are really fascinating. And yeah, so completely, completely derailed your conversation, but I have a feeling you're going to have something interesting to say.
Yeah. No, I mean that's related to that for sure. And yeah, basically and that's funny because I had also Alan Downey on the show for his latest book, and that was also definitely about that.
Yeah,
So yeah,
probably overthinking it was the book.
yeah,
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 it's
yeah, yeah,
great, 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 great.
and yeah, great book. And so basically, they like this NGO, they had these survey data, right? And they're like, but their clients have questions, and their clients are usually um, media or politicians, and it's like, yeah, but I'd like to know on a geographical basis, like in these electoral districts, what do people think about that? Or in this electoral district, female, educated of that age, what do they think about same-sex marriage? That's hard to do because like polling at that scale is almost impossible. It costs a ton of money, and also polling is harder and harder because people answer less and less to polls. And so at the same time, the polling data becomes less available and less reliable. But you have people who get more, interested in what the polls have to say. It's hard, and there is a great method to do that. So what we did for them is come up with a hierarchical model of the population, because hierarchical models allow you to share information between groups. So here the groups could be the age groups, for instance. And basically knowing something what a hierarchical model says is, well, age groups are different, but they are not infinitely different. So learning about what someone aged 16 to 24 thinks about same-sex marriage actually already tells you something about what someone aged 25 to 34 thinks about that. And the degree of similarity between these responses is estimated by the model. So these models are extremely powerful. I love them. I teach them a lot. And actually, in the advanced regression course, the last lesson is all about hierarchical models. And I actually walk you through a simplified version of the model we did at PyMC Labs for that NGO called SAC in Estonia. So it's like a model that's used in industry for real. So you learn that. That's a hard model, but that's a real model. And then once you've done that, you do something that's called post-stratification. And post-stratification is basically a way of debiasing your estimates, your predictions from the model, and you use census data to do that. So you need good data and you need census data. But if you have good census data, then you're going to be able to basically reweight the predictions from your model. And that way, if you combine post-stratification and hierarchical model, you're going to be able to give actually good estimates of what females educated age 25, 34 in this electoral district think about that issue. And when I say good, I say I want to say that it's like the confidence intervals are not going to be ridiculous, right? It's not going to tell you, well, this population thinks is opposed to gay marriage with a probability of 20 to 80%, which just covers basically everything. So that's not very actionable. No, the model has like it's more uncertain, of course, but it has really good a really good way of giving you something actually actionable. So that's like that was a big project. I can dive into some others if you want, but like that takes time. So
No,
I don't want to derail the interview.
that's great and highly illustrative. It gives that sense of how, with a Bayesian model, you can be so specific about how different parts of the data interrelate. So, in this case, for example, you're describing having different demographic groups that have some commonality, like all the women, but different age groups of women as a as subnodes of women
Yeah.
in general. And so that way you're able to use the data from each of the subgroups to influence your higher level group